Okay, now what I want to do is try the same method, stoichiometry, to another problem in the book. Let's look at a problem 958 on page 281. Okay, here we're not just dealing with moles, we're also dealing with grams. And so you're familiar now with the ratio, the conversion that deals with ratios in the balanced equation. Now there's another conversion that you will use is the molar mass conversion. And that's the molar mass is how much it weighs, how much the substance weighs per 1 mole. And you get that number by adding up the masses from the periodic table. Okay, so it says gasohol is a fuel containing ethanol. And ethanol is given by the formula C2H6O, and that's why it's in parentheses there. Okay, that ethanol burns in oxygen to give carbon dioxide and water. So first thing you have to do is balance the equation. And that's what you always have to do with stoichiometry. You must start with the balanced equation. So where's my equation? Here. Okay, I'm trying to hold my iPad while doing this. That's why I might be a little bit shaky here. But anyway, it said ethanol reacts with, that means add it to oxygen to produce carbon dioxide and water. So this is the equation, and we must balance it. And so to balance, you just start off very simply. The easiest way is to balance from left to right. My oxygen is a pure element here, and most of the times it's easier to balance those kinds of materials last. So I have 2 carbon, and I have 1 on this side, so I'm going to put a 2 here. That gives me 2 carbon, and it gives me, I'll do the oxygen last. So I have 6 hydrogen here, and I have 2 here. So if I put a 3 here, that gives me 6 hydrogen. So my hydrogen and my carbon are balanced. So that leaves me with 2 plus 1. That's 3 oxygen on this side, and I have 2 times 2, 4, plus 3, that's 7. So I have 3 over here. So I have to figure I need 7 over here. So if I I have to think about this, it's 3 here. That would give me 6 plus 1, 7. So you can check it, but it's balanced. So the next problem says, how many moles of oxygen are needed to completely react with 4 moles of ethanol? And so 4 moles of ethanol is what's given. So you start with the 4 moles of ethanol, and to convert from moles of one substance to moles of another substance in the equation, use these ratios. So it's a 3 to 1. So that gives me 12. That was easy. The next problem says how many moles of oxygen are needed to completely react with C. If a car produces 88 grams of carbon dioxide, how many grams of oxygen are used up in the reaction? So now I'm starting with 88 grams of this substance. It doesn't matter with stoichiometry whether it's a product or a reactant. It's the same thing. If it's the product, that's how much you expect. If it's the reactant, that's how much you need. So 88 grams is given off. So how many grams of oxygen were needed? So you start off with 88 grams. Now I need to convert this to moles. And to convert it to moles, I use the molar mass. The molar mass of carbon dioxide is 44 grams. There's 44 grams of carbon dioxide per 1 mole of carbon dioxide. I get the 44 by adding 12 plus 2 times 16 from the periodic table. Now, if I stopped at that conversion, or that calculation, that would give me moles of CO2. Now I want to convert this to moles of oxygen, so I use the ratios from the balanced equation, 3 and 2, and I put the 2 moles of carbon dioxide on the bottom because I want to be able to cancel this with this. That leaves me with 3 moles of oxygen on top. And so if I were to stop right here, 88 divided by 44 times 3 would give me moles of oxygen. But I want grams of oxygen, so now I need the molar mass. And before I was dividing, now I'm multiplying, and the units will let you know which way to go, because I want to cancel out the moles, which are on top here. So I'm going to put the moles on bottom and the grams on top. So this would leave me with a unit of grams per grams of oxygen. So when I take 88 divided by 44 times 3 divided by 2 times 32, I get 96. The last one says if you add 125 grams of C2H6O to your gasoline, how many grams of CO2 and water can be produced? So I'm adding this to my gasoline. I'm not concerned. The gasoline it's going to produce carbon dioxide and water too, but it didn't tell me how much. So that's not the issue. The issue is I start off with 125 grams of alcohol, ethanol, and how many grams of CO2 will be produced. So I first got to convert grams to moles of C2H6O, and I do that by calculating the molar mass. And I did that over here. You see 2 carbons, 6 hydrogen, and 1 oxygen gives me a molar mass of 46, if I've done that correctly. And so I'm dividing by 46 on the bottom because I want the grams to cancel out the grams here. I can't stress how important it is to do it that way. Okay, now if I stop there, 125 divided by 46 would give me moles of ethanol. So now I want moles of CO2. So I go for my balanced equation. There's 2 moles of CO2 per 1 mole of the ethanol. So 2 over 1. I'm putting the 1 mole of C2H6 on the bottom, so it cancels with that. And now if I were to stop here, I would have moles of CO2. But I want grams. So now instead of dividing by my molar mass, I'm going to multiply by the molar mass so that when the moles here on the bottom, we'll cancel these moles here, and I get 44 grams here. And when I multiply 44 times 2 divided by 46 times 125, I get 231.1 grams of CO2. You can do a similar thing as shown for water. Here, the difference between this one and this one is that I'm using from the balanced equation the moles of water per mole of ethanol, and I'm going to use the molar mass of water. 2 times 1 plus 16 is 18, and so I get 46.7 grams. I can't stress that this is the way to do stoichiometry.